what we try is to extract as much information as possible that we find valuable for any file. So you can get all of these signals and you can decide. We are not creating a verdict by ourselves, we are simply aggregating everything all together. Now, with the AI, in addition to what you described, which is all right, besides all of this, you can go and analyze the code itself. Can you provide an explanation of what you see? What are the red flags? Can you summarize IOCs? In addition to all of this, think about the possibilities.
Welcome to another episode of Mandiant's Defender's Advantage podcast. I'm your host, Luke McNamara. Today, I am pleased to be welcoming on Vicente Diaz, the Threat Intelligence Strategist at VirusTotal. Vicente, good morning to you.
Good morning. How are you?
I'm doing well. I'm mostly recovered from MWise. We are recording this a week afterwards, and that's relevant in this case because we're going to touch on something that you recently spoke about at MWise, which is using LLMs to analyze malware executables. So yeah, let's dive right into it. Maybe, you could begin with sort of the idea for this talk and kind of how you were approaching this whole concept.
Yeah, absolutely. Actually, this is something I was, as you very well said, discussing during NWise, but I also discussed it previous year. And it's something we presented during RSA 23, which was the idea of code insights. So basically, we were fascinated with how LLMs were able to create amazing code from any description. And we were wondering, okay, what about the opposite? Can they create like an amazing description from any code? And it turns that they do. So why don't applying this to any kind of malicious code so we can get like an explanation of what the code is doing? Which in some cases it could be trivial. In some cases is very hard and complicated because maybe there are thousands of lines of code, they are obfuscated, and you want to have a quick answer. There are more and more attackers that are using scripting languages. This was very interesting and useful. We could throw this to a bunch of PowerShells, macros, whatsoever, and get the description. Like, okay, I think this malware is malicious. I think it is doing this and that. And this is awesome because for the first time, we don't have only a verdict. We have a full explanation, which you could agree or disagree. But when you only get an A/B verdict, okay, there is not much you can do. It's like it's malicious. All right, that's it. And especially was interesting covering all these gray areas. Like, let's say you have in your infrastructure some script that is scanning for some vulnerability. Is that malicious or not? So if I'm an AV, let's say my major incentive is to protect the endpoint. Now, this is not really affecting my endpoint, maybe suspicious, but it's unclear what will be my verdict. That really depends on every AV. In this case, you will have a complete explanation. Look, I found this, and this is doing this and that. So you can better align this with your policies, and you can better decide what to do in every one of these, let's say, gray cases where it's not very clear what to do. All right. So after this long premise, what we wanted to do is, okay, what is the next step? This is working well for all these scripting languages. Can we use the same technique to analyze all types of malware? And especially, can we do this to analyze Windows executable files, which is by far the most the biggest number of samples we have by any other type. And this is how this project started a few months ago. We started playing with this idea and we started defining different procedures, and architecture. We started doing tests. So basically, what I was doing last week was discussing some of these main ideas: what work, what looks like a promising path, what are the different blockers, etc., etc.
So to back up for a second, probably for most of the folks out there listening to this, people are very well familiar with VirusTotal. It was one of the central tools I was using when I first started my career in cyber threat intelligence. There's a vast trove of intelligence and data that can be gleaned from that. But correct me if I'm wrong, but sort of essentially how it works is you can upload a file into the platform. There's various AV engines running that can detect and fire on if it's malicious, what those various AV engines will detect it as. But beyond that, there's sort of limited insight you can get into what the code in these files in this potential malware is actually doing. And so that was sort of the concept with code insights, is that you get more of a window, and also potentially uncover false positives, false negatives, where maybe something hasn't fired on a particular AV detection, but what the code is actually doing is something malicious. It's asking for permissions it shouldn't have, or it's doing some other sort of surreptitious feature. And then where you're kind of going with this now is saying, okay, we've been able to kind of use this for scripts and some of these other things, but let's approach thinking about this with kind of your researcher hat on. Let's approach one of the big use cases that anyone in security has, which is analyzing, reverse engineering, malware binaries, Windows executables in particular, and see how this applies here. Am I getting that kind of correct?
That's perfect. This is what we wanted to do. And actually, you're right. Before that, what we had was aggregating different security tools in VirusTotal. What we try is to extract as much information as possible that we find valuable for any file. So you can get all of these signals and you can decide. We are not creating a verdict by ourselves. We are simply aggregating everything all together. Now, with the AI, in addition to what you described, which is all right, besides all of this, you can go and analyze the code itself. Can you
Yeah.
provide an explanation of what you see? What are the red flags? Can you summarize IOCs? In
Yeah.
addition to all of this, think about the possibilities. You can also provide to the AI all this contextual information. So suddenly, in addition to this capability to read the code, you also have the capability to provide all this contextual information and even allowing the LLM to make function calls to our API in case that it somehow needs additional information about any indicator in particular. So potentially, this is like having the capability from one side to summarize, from the other to unify all these verdicts in one single place, in addition to what it does by itself, which is reading the code, which by itself, as you said, is absolutely phenomenal because probably if you ask any security analyst what is the most painful and time consuming and where you need more expertise, it will be reverse engineering.
So I think you kind of touched on this, but with the problem that you're trying to solve here with analyzing Windows binaries, well, first maybe to back up a second, are you doing static or dynamic analysis in this process?
So this idea is full static analysis. But one of the beauties is that, and this is something that we discover, is like, all right, why we don't include also the dynamic analysis in the prompting? So the LLM can use this as a reference and maybe compare, maybe distinguish between one and the other. In some cases, we found very interesting examples. Like the LLM was saying, well, I identified this, and that by static analysis. And I couldn't identify this and that, sorry, the dynamic analysis, because we were using, as I said, dynamic analysis as well in the prompting as additional context. So it was saying this couldn't be identified in dynamic analysis because it was avoiding detonation by this and that technique. So that was phenomenal. Like, wow, it's not only using this as a reference, it's only like conscious that, all right, this is dynamic, this is static. I found this, I couldn't find that in dynamic because it's using this or that technique to avoid analysis. Of course, this is the ideal case, but we have seen such examples, which is speaking of the potential.
So I guess go back to what I was thinking about with this. When you set out to play around with this and figure out, how you can employ LLMs in malware analysis, especially with Windows binaries, was there a particular part of the malware analyst workflow you were thinking this could augment or replace?
I think that nobody has like at this moment in part of the analyst workflow in this pipeline the part of reverse engineering, like something you can always count on. This is something that in very rare exceptions you will be sending to your team. In very rare, I mean, like talking about the global picture. So I don't know what is the percentage of cases where you have the capability, resources, and you can justify to put like a bunch of folks to work into reverse engineering something for days, maybe weeks. It really depends, right? In some cases, there is no other solution. And actually, our idea is not to replace all these reverse engineering resources at all. Is to make their life easier. So just think that for most of the cases, you can actually incorporate this into your pipeline, this analysis pipeline you were mentioning, and you suddenly have some ideas around what the sample is doing. I would say for 80% of the cases, this is more than enough. It's like, oh, well, okay, we know this and that and this. So we can move on. We don't really need more. In some other cases, you really will need the full analysis. And for this full analysis, when you have the experts, it will also be useful that the LLM is suddenly identifying, well, I think this and that function are used for encrypting. I think here is the key. I think here is this or that capability. And suddenly you are getting close to what could be a solution. In some cases, we saw like it was correctly identifying some capabilities for, as I said, encryption or whatever. It was failing, like in creating the Python code to decode it, which is fine. But at least, as a reverse engineer, you have halfway done or even more. So I think that if we at some point are able to provide this consistently, this analysis, and we can really inject this into any analysis workflow, this will be really making life easier for many, many different teams. And at the same time, it will be helping for this elite team to focus on what is really relevant.
Yeah, I can imagine, thinking back to roles I've had in analysis in the past where actually using VirusTotal, I would go through and I was looking for files with a particular CVE that at the time a lot of Chinese cyber espionage actors were employing. And especially looking for files that had been uploaded with some interesting titles that could potentially provide an indication as to the lure content and nature of these operations, pulling those files down, dropping them into Sandbox, trying to get at least initial detection, maybe a C2 that could help with that sort of triaging before I kicked it over to an actual malware analyst to look through. So I think there's a lot of value in speeding up that process and providing maybe people who don't have the capabilities or time to do a full malware breakdown and reverse engineering to at least triage files and say, okay, do I want to examine this further? And then also having that actual code insight into what the malware, the files attempting to do, I think that could be incredibly useful as well.
There is one interesting aspect that actually I didn't really highlight, but I would like to discuss with you, which is regarding attribution. So maybe you remember things like the Marvel framework. I think this was released with Bolt 7, if I'm not mistaken, and it was injecting different languages to different variables, functions, whatever. So you could select Farsi, Mandarin, or Russian, or whatever. And this was kind of how attribution was done in the very old days, like trying to define some strings in some particular language. We, of course, understand that this is not the case anymore. But one of the things I observe when providing some of the results is that obviously the LLMs, they don't really care what language you are using for absolutely anything. And there were a few cases where I saw some of the functions were written like in Cyrillic or in Chinese characters. And I was thinking, well, the beauty is that the LLM absolutely doesn't care about this. What will be attribution in a neutral model that could simply identify these factors regardless the language that they are written? And I was thinking this could like maybe introduce a different uh, angle to attribution, like having a much more neutral capability to do so, at least language related. Maybe we are a bit late for this because I'm not sure this is anymore the main focus. But I thought that, listen, when we were doing the first version of Coding Site, we detected many different abilities we never thought of. One of them was detecting what are different text file types. Just let me explain to you. You can very easily detect different file types by the magic numbers, the magic bytes that are at the very beginning of the files. So this is an MC file, this is a whatever, right? A PDF, this is a Mako, whatever. Now, when there is a text file, it shouldn't be way simpler, but text files could be used for absolutely everything. Could be configuration files, could be files that you're like storing text for. So there are so many different types of files, including programming languages like PHP or HTML or whatever, that finding what this file is about is very painful. It's very painful to have a good method to parse them with all these regexes to find, okay, this is that. It's really bad. And it never worked for any, in a good way, for any of the tools we have until we found LLMs. And LLMs are fantastic at this because they analyze the content and they say, okay, this file is this. And we found more than 100 something type files that are text files from all kind of systems we've never heard of in our lives. So thinking about these emerging kind of properties, or not emerging properties, it will be more like unexpected twist of the story. That's why I was thinking that maybe in terms of attribution, there is some angle here we could explore.
Yeah, I'm thinking through some of the, notable public examples of, maybe complex malware or malware that has kind of come on the scenes for the first time in a notable intrusion or event. And it becomes public, and you have security researchers around the globe in real time kind of working through and trying to decipher, de-obfuscate, analyze the malware, and even some of the ones again that are not public, things that we've covered in the past, in our work. You never know certain things that are going to be valuable when you're looking at a set of activity, a campaign overall, but even down to a specific piece of malware. And so being able to kind of bubble up and surface some of those irregularities or features of what this file is doing, I think is incredibly valuable.
I think this is part of the potential. So regardless, like how good or how bad we are in achieving this, one of the things I love about LLMs is how they can consider so many different data points that for us it's hard to understand which one is relevant or not. You need to do this data science analysis first, and then start playing with all these factors. But in terms of LLMs, you can throw everything, well, to some extent. One of the things we learn also during our analysis is that you can throw everything. It's a nice concept, conceptually, like put all the context, but we need to be very careful not to bias the answer. Just let me put an example. If you in the prompt include, let's say, okay, here is the disassemble or decompile code for this sample. Can you tell me what it does? And by the way, this is some additional context. And the context is this restricted configuration file from the malware itself, which includes some C2s, whatever. Then the answer from the LLM will be quite biased to use this context that you introduce in the prompt, and it will be highlighting this C2 anyways, regardless it's found in the code or not. Well, and keep in mind all of this is non-deterministic. Keep in mind this is based on a few hundred samples that maybe we use for this particular case, and this could vary. Also, LLMs model are evolving every day, right? But we need to be careful when prompting, because this can influence the answer from the LLM, just because I think, okay, if this is in the prompt, somehow I need to make it will put a higher weight to this. So we found that one of the best solutions was using these function calls, because this allows the dynamic to the LLM to dynamically prompt, well, not to prompt, but to query, in this case, VirusTotal and potentially any other system, to get this context when needed. And this really helps to build a more solid answer. And this is what we want at the end of the day. We want repeatable answers. We want consistency among any answers, because for the moment, this is something we need to carefully design through prompting and everything.
So we talked through, some of the benefits, obviously, to using LLMs for this sort of work. What were some of the challenges you ran into when you were doing this project and you were looking at, how LLMs might best analyze malware binaries?
So actually, we didn't even consider this idea for a long time, just because the amount of tokens needed in our prompting to be able to get an answer. Think about some decompile, or even worse, disassemble code. They are huge, and this is like this big piece of code that you're sending to the through the prompt. And depending what you're prompting, is even increasing complexity. If you are putting additional context, it's even worse. So this is something we didn't even think of doing for a long time until the new models of Gemini.
When you were initially starting this, what were your prompts when you were putting this into Gemini, I'm assuming? Like, how would you phrase the prompt? Would you say, tell me what this file is doing? Is there anything malicious this file is doing? How would you phrase that?
Yeah, well, there was also an evolution here. So we started with something simple, just understand the whole range of answers that we could get and how deep we could go. And what is the point where we want to stop, just to provide something solid for VirusTotal users, right? But we started with something simple, like, hey, do you think this is malicious? You're a security engineer. Here is the code. Here are your references. Here is, I don't know, whatever context you want to add, dynamic analysis or this or that. And can you tell me what you think of this file? What are the main functions? What are the main IOCs you can extract? What is it doing? And tell me if this is malicious. So we get like a very easy way to compare maliciousness, which is, let's say, the minimal answer that you can get, so you can compare results and see how good or bad is doing, right? From here, then you want to go into something more detailed, like what are the different capabilities. And here we were using Kappa as a reference because Kappa has its own ontology on different capabilities. So we were thinking this will be a nice output that we can very easily cross-check with dynamic analysis, because in the sandbox we are also running Kappa. So okay, this is what the LLM is saying. Like, these are the capabilities from our sandbox. Let's cross-check them and see what we can infer from here. Unfortunately, this was not not that easy to do, because some of the capabilities, they are only seen dynamically, some of them they are only seen statically, and also there is a different weight for every capability, because Kappa works with kind of Jara rules. They are not Jara, but they are similar to Jara rules conceptually. So they are checking for this and that into the memdam. If we find this, then we will note that we will flag this capability is being used. So not all the rules are the same. There are different number of rules for different capabilities, etc., etc. So the results are not 100% comparable. And in our last round of prompts, what we were incorporating is these function API calls. But still, we are halfway with this. We want to provide the LLMs with kind of cyber chef capabilities. So whatever it finds, they will have all the resources to provide the right answer, because we still get some answers that are like right to left instead of left to right when it finds something in memory. XOR is doing pretty well, but for some base 64 also, for some other stuff that could be also easy to decrypt or de-obfuscate, sometimes it's not that good. So just to provide a more consistent answer.
Yeah, you mentioned de-obfuscation, and I can imagine that would be a challenge with some more heavily obfuscated malware samples. Anything in particular you ran into there in terms of technical challenges?
Well, this is obviously the big problem. When we find a packer, we find something obfuscated or something that is encrypted. How we deal with that? So first of all, we still wanted to understand what are the native capabilities of LLMs without doing any of this. We understand that the analysis ratio will be way worse, but we want simply to know, all right, if I give you this, how are you reacting? And usually it's playing around these capabilities. Like, okay, there is all of this that is encrypted. I have no idea how to analyze this, but this is the rest that I see, which could lead to false positives naturally. So how we deal with that? Our idea is to create some kind of decision tree. So let's say we find something that is packed with this packer, or something that is in .NET, or something that is in whatever other interpreted language. Now, what tools we have at our disposition to extract the real malware from here? In some cases, all right, instead of using IDA, let's use this other decompiler because it works better with this type of files. Or this one, we have no idea. Let's simply detonate in memory. Let's get the main dump. Let's rebuild. Let's try to rebuild the IAT. And from here, let's then send to IDA. And the compile code we will do as usual. In some cases, it looks like disassemble is better than the compile code. So, all this decision making based on our experience can build this decision tree, which will allow us to minimize the number of resources that we need to to use for every type of file instead of blindly sending to to the most complex pipeline. At the same time, provide the optimized results. In some cases, maybe we want to provide additional context for this particular type of file, or we will have additional references because we find it's of the same family that we already analyzed, this kind of stuff. And this is our approach, but obviously, this is the biggest problem. The same than if you ask to any reverse engineer, what is the problem when analyzing code? Well, it's size, it's complexity, it's encryption, obfuscation, packaging, etc.
I mean, I can imagine one use case. I mean, you just mentioned comparing files, comparing malware. Let's say you have something that you suspect to be on its surface a variant of another malware, part of the same malware family, but it appears to be different. Maybe was used in an operation that doesn't seem to be the typical threat actor that uses that maybe exclusive piece of malware, or you presume to be exclusive in the past. So maybe you want to compare it and say, what are the differences between this version of malware and this other one that appears to be a variant? Something like that, I can imagine, would be present some interesting data or outputs. But I guess maybe with that example, or even more generally, were there anything that you found surprising when you were doing this research?
Well, I was surprised how good in what cases are the results without giving any clues. How in some, I remember some Mirai cases where the results of the malware analysis were like, okay, here are all the different capabilities, and here are all the different functions that are doing this, and here are the commands that they are receiving. I guess these are the ideal scenarios where the malware is not encrypted or obfuscated and is giving you all these results. In other cases, it was the opposite. It was very hard because we did non-effort, right, in getting the destruction of the real sample or rebuilding it or providing it in a good way. I think that all in all, and you were actually mentioning some of the most advanced scenarios we can find, like false flags or repurposing malware, or minimal changes, and things like that. And I'm also curious about all of this. We are just scratching the surface by getting this early analysis. We are surprised. At the same time, we are aware of some of the challenges. But I'm also very excited about how we can use this for more complex analysis, more complex capabilities. And I'm excited about the idea of the more context we can provide around the sample, how this can benefit everything. And as we keep building a better knowledge base, because one of the things we also decided to do was to create some manual way to analyze this. If you are familiar with IDA, we have the VirusTotal IDA plugin, and here we implemented the capability to interact with Gemini. So if you have no idea what this function is doing, you can ask, and you will get an answer, and you can also put your notes and keep feeding the knowledge base with whatever you're finding. So eventually, when all of this is something way more common, is something that we keep feeding, we keep learning, I think it can solve this 80%, let's say, problem of reverse engineering to some extent. But still, I'm the kind of guy who is interested about the extreme challenges that you were mentioning, and I will be very curious. I would love to dedicate some time to play with these more extreme scenarios.
So we talk here at Google about where generative AI can play into the security lifecycle, security workflows in the sort of context of threat, toil, and talent. And I think this example really hits on all three, right? Being able to identify malware, being able to identify binaries, maybe even ones that are detected as false negatives off of traditional AV detections. So finding those threats faster. But then I think especially the toil and talent, which oftentimes seem to converge, right? Being able to take maybe a junior analyst who's not as well versed in malware analysis, or even someone who is more senior, but this can be very time extensive, and being able to do more using LLMs to analyze malware, get that output faster and back into the workflow. This seems pretty promising from kind of your research here.
Yeah, actually, it's something that is like the ideal vision, right? When you can provide a simplified answer to all the complexity that is behind malware analysis, and where you can also summarize everything you know. Because even if we are able to provide like this LLM answer, it's yet another signal that you have amongst all the different signals that you have. And this is one of the biggest problems, which is complexity. You have so many signals. Which ones you think are more relevant than the others? How to automate this? How to detect anomalies? How to build a playbook around all of this? It's not simple. Now, LLMs are here also ingesting all this great amount of data, and they are able to provide a simplified, and I would put quotes around simplified answer, because the beauty is that you can answer different things, and you don't really need just to take my answer. You can keep interacting. So interaction with the samples is one thing. If you need like deeper knowledge, this is something that eventually we will also provide, and you can keep talking, you can go for specific questions, and also think about all your playbooks around your CMs or whatever, where you can also put LM to play, and you can optimize whatever you are detecting. You can have different policies, and you can put more weight in one or a different aspect depending on your own environment, priorities, risk profile, etc. And not only that, also for humans, having the capability to digest all this super complex information. Listen, when I remember many years ago, but there was this poll in Black Hat, and they were asking people like, how overwhelmed are you with the amount of information in the security industry that you need to deal with every day? And everybody was already overwhelmed. This was maybe, I don't know, more than 10 years ago or 10 years ago. And just think about now, like the amount of mental power that you need just to keep up to the news and to understand what are the implications. This is kind of overwhelming. At some point, nobody can really process that. So having the capabilities to, all right, this is my situation, this is me, this is all the information that was published today, yesterday, in 1 week, or forever. Just tell me some ideas, taking this, that into account. So I see so many different options, that they can reduce enormously the time spent in all these tasks. That it's really exciting. It's just we need to make sure we put everything with the right priorities in order, so everything makes sense in our way. Because also we can make the mistake of trying to run ahead of ourselves and just think that, okay, tomorrow everything will be solved. It's not like this, but I think we are making great progress in all these directions.
So, with that eye towards the future and kind of wrapping this up, what are some of the things that you want to examine and research further about where LLMs can fit into this workflow and process around analyzing malware? What are some of the things you're hearing from VirusTotal customers or others in the security industry? And, from doing this project, what are some of the things that you especially are interested in kind of pulling the thread further?
Oh, this is very interesting because there is a whole range of expectations and hype around this. There is people who think everything will be solved, people who is absolutely skeptic because they've been dealing with reverse engineering for years and they know how complex it is for some of the cases, and they are kind of non-believers that this will happen. I understand that some people in the industry got sick of the hype very quickly, and they don't want to hear about LLMs anymore. Still, it's undeniable that there is value on this. Me personally, I'm interested in being able to put this in production in a right way. So we start handling this problem and then we will keep polishing. I'm interested in finding this optimal decision tree we were discussing. So we get reasonable results for most malware families and we start getting more people engaged into this, get more feedback, etc. If we go to discuss about our users, customers, etc., everybody's super excited about that. And they're like, hey, yes, we want more about this, and everybody is, as I said, running ahead of themselves. And we also want this to be customized for us, customized for our profile with this and that type of information. We also want to bring our own intelligence. All of this will be doable, and all of this will be possible. But from the research side, um, I'm interested into putting some effort, and here is kind of a different angle to this, in how this can help us as well to detect all the threats that are not malware based. Because I think that most of the attacks we are seeing nowadays, and this is a bigger warning for all companies, are cloud related, and they are malwareless attacks, or like some cookies, some impersonation, some credentials, whatever.
Identity based attacks.
Exactly. And I think there is like a lot of, there is a big need to understand, okay, how this can be analyzed, what are our capabilities, and how we can relate this to anything else. And I think this is a very interesting area of research, to understand with what we have, what kind of anomalies can be detected, what kind of stuff can be prevented thanks to having these tools. So it's kind of completing the circle of the analysis. We want like to full analysis of the most complex stuff, to the analysis of no malware, which is kind of the ultimate evolution of malware, right? Like I'm not even here, and I'm doing this.
Well, it's been fascinating to watch, what has already rolled out, notably with Code Insights into VirusTotal, and I, along with I think the entire industry, will be curious to see what comes out next. So, Vicente, thanks for sharing this research. I'm not sure if your talk is going to be out on YouTube, if that was recorded or not. So, if so, we'll include a link in the show notes. But thanks for spending some time talking about this, talking about your research here, and have a great rest of your day.
Thanks for having me. It was a pleasure.